Hello. So, welcome back, ladies and gentlemen. I'm Siddharth Maiti. I'm the senior analyst for ARC Advisory Group, and I'll be moderating this session. In this session, we will be discussing about industrial AI and the various end-user experiences of using artificial intelligence in their respective field of operation. Now, we have speakers from a wide sphere of end-user industries, we have Mr. Deepak Sharma, who is the head of department of IT at Udaipur Cement Works, a subsidiary of JKLakshmiCement. We then have Mr. Jitendra Bhavrani and Mr. Omkar Prasad Jana. They are from Nuclear Fuel Complex, and we also have Ms. D.S. Lata, Discipline Head, Power Business Unit, Instrumentation and Controls from Tata Consulting Engineers. Now, to just give a very brief introduction about the session. So, industrial AI is basically the use of artificial intelligence technologies to optimize industrial processes from manufacturing to energy systems. It helps machines and systems learn, adapt, and make smarter decisions, which helps in reducing the downtime, improving the process efficiency, and also enables predictive maintenance very effectively. So simply put, it brings intelligence to the machines that power our industries. For end users, industrial AI means fewer breakdowns, faster repairs, and smoother operations. So because systems can now predict issues right before they happen. Ultimately, it helps teams boost productivity, reduce errors, and keeps systems running efficiently. Now, I would like to introduce to our first speaker, Mr. Deepak Sharma. He'll be presenting on artificial intelligence solutions for complex use cases in cement manufacturing. Over to you, Mr. Sharma.
Hello, good afternoon all. Good afternoon all, and it's a very tough task to take any, you can say, session after lunch, because it's difficult for both, because I have to create that interest that you never feel lazy. So I am here to showcase you the cement manufacturing. I am from the cement, and because in a cement we generally think that we are just utilizing the product provided by the OEMs. We are also doing the same, but because company in a JKLakshmiCement and Udaipur Cement Works Limited, there is a culture that some of the use cases they identified that we are also struggling with OEMs also. And because these use cases need lots of emphasis on the process, on the domain expertise, so it is not possible for any OEM to spare some AI research team just for providing the solution of a use case. It may be that it can be replicated, but it's purely depend on the benefits and cost. So we take this, and company provide me the challenge. I was a SAP team member. I was SAP ABAP, then after that SAP functional, then SAP ABAP functional, and then SAP functional. But in 2010, company provide me challenge to lead the team of IIT and many institute researchers and try to solve the industrial problem with the help of artificial intelligence. That time artificial intelligence was not that much. That time automation was the main focus. But as technology, you can say day by day, everything within a month, every time when we see that something new is coming. So day by day research is coming. So this is the aim of our company. I am from Udaipur Cement Works. So this is the core in our, you can say, vision and mission, that we must, as you can see the vision, leveraging technology and enabling human capital. So we are not ignoring the power of human. We all know that the neurons structure available in our mind cannot be, you can say, match. It's huge, its neurons layers is very huge, and we will try to showcase that if we can utilize a little part of the human intelligence in our computer vision or AI related task, we can solve a number of use cases in any manufacturing company. So generally these kind of award take care by the IT companies, the IT use cases in cement. So it's a proud moment for our JKLakshmiCement and Udaipur Cement that we also participated in this event and we selected as the best use cases. These are the all, you can say, tools generally used by any good company, because it's not possible to develop everything in house. So we are also utilizing the power of available technologies, either in place of SAP, either in cyber security, because it's their expertise in particular field. For example, we will communicate with some cyber security expert who will provide OT/IT connectivity, so we cannot match that expertise. So we also utilizing the available technology to enhance our performance to solve the use cases which is available in our company. But I will more focus about the use cases. We found that we struggle with OEMs also. So this is our plant. It's a unique plant in Udaipur. Udaipur is a tourist place, you all know, and this plant achieved a number of, you can say, achievements. It's the first cement plant which used solar panel in, you can say, their mine pits is filled with lot of water, so they utilize this with floating solar place in, you can say, in these areas, and we're the first plant in cement which utilize this. We are very much expert in energy utilization, energy consumption. We are the, you can say, all these field we are expert. Now we will talk about the concept that if we will not have a concept in our, you can say, all our culture, then innovation will not come. So our management just say us that you just think that if you can provide some intelligence in a machine in any way, it's not that you will make a mimic of human, but at least some task in industry in such a way that can be easily done by the machine if you will provide little bit intelligence in this. So this is the concept. We at least machine can also think little bit. Now I just talk about the concept. We all know about the power of our eyes. We can see and we are doing a number of tasks with the help of our eyes. I think it's not possible. Still I am doing PhD, still it's not possible to mimic a human in AI. You can analyze that you are all seeing, you are all doing a number of work, you are analyzing. If I am moving this hand, you can analyze that Deepak is moving that hand. So you can see the power of your eyes. So we also analyze this and try to utilize this in our use cases, that if we can do the same with computer, if we will provide the computer some intelligence that they can read the image, collect the intelligent information from the image, and then process as per the task. It may be collaborate with artificial intelligence machine related task, or it may be that it can take some simple automation related task. So computer vision, we all know all the field. It's clear that in a simple way, if we can say, teach computer to see, understand image, video as human do. Not just like human, but if some part of human they can do, they can solve a number of problems. So these are the three use cases I will discuss, because we have done lots of work towards these use cases. So I will explain in detail. We actually created a analysis, and during this we create a report, and after that report we identify 30 plus use cases in our cement specific sector related to computer vision, which can be solved only with the help of computer vision, because it's not possible to put sensor at every place. Even sensor cannot work some place. I will discuss. So these are the use cases. First use case is our packing plant is struggling with that how they can count the cement bag. One way is we will standardize the system. Everything is coming in a proper way. That is the one way. Its counting is very easy with the help of sensor. But other way is we have create a system in such a way, intelligent system in such a way. If mechanical there is some problem, that can be taken by the system. So we will work on that approach. The second is kiln health monitoring. We have discussed this, how we utilize the power of you can say thermal camera to intelligent our kiln operation. And the solution of one use case related to mines, that how mines jaw cursor jamming problem can be solved with the help of computer vision. And I am not talking about the rocket science. These are the simple use cases, and I will show that how these can be solved. You are also analyze. The first is the objective is simple. We want to create a AI based system which can work in n number of system, which can recognize the bag, it can count the bag. It can count the bag is n number of environments. Mean to say sometime in a packing plant one bag overlap on other, so that time it's very tough for the sensor to count such kind of problem. So I will show you such images of cement bags. You can see on a running belt, this is the condition. If we will put a sensor, it's not possible to find such kind of environment in such kind of use cases. So we will try to create a computer vision model. If we talk about the computer vision model, it's a simple. We just collect that images, label the images as per the requirement of our objective, and then train the model. Just like we train the human, we train the machine and create a model, and that model will work like a human. So now this is the result of this. As you can see, this is orientation of cement bag will not do anything. It will come in any way, it will count. So if our system is not mechanically strong, at least with the help of latest technology, computer vision, we can solve such kind of problem. And in second, it's not running. Second. Here you can see the big challenge is how we can recognize the bag, which brand bag is running on the belt. So this is also possible with the help of computer vision. You can see that at one belt there is a platinum cement, and other bag there is cement JKLakshmi. So counting with you can say accuracy of brand. So this problem we solve, and this is done, everything done by our own in-house team. Some part done by the research team from IIT students, some part done by our team, and some part our own employees and other department employee also. So this is the use case. We just take two objectives, the counting the bag and brand recognition. But if you will see the physical position in a cement sector, when a counting bags are running on belt, you will find n number of use cases. Jamming is the major problem. Belt idle running is the major problem. Any human is near the belt is a major problem. These all can be solved with the help of computer vision. And because processing is high, so we use the GPUs and it's giving the perfect results. So when we compare it with with you can say available systems, IR sensor, manual counting, so we found that every you can say objective can be fulfilled with the help of accuracy is high, overlapping is this system, manual counting and IR based sensor will not work in case of heavy overlapping. And we tried this system at multiple locations. We have wagon loading system in rack, we have cement truck bag counting, we have n number of location in belt. we tried and we find accurate result at every position. It may be that because if system is not trained at that environment, we just collect the images and retrain the model and it's localized. But the second use case is related to kiln. If anyone from the cement industry, kiln is the heart of any cement plant and its running cost is very high. So it's a huge means to say all the raw material consumed by this particular equipment, coal consumption, raw material consumption, electricity. So if we can do any kind of simple or small use case solution related to kiln, we can give benefit to company and to the natural resource consumptions also. So the same way what we do, it's not possible because the kiln temperature is very high. It's 1400 degrees centigrade, so it's not possible to put any kind of sensor at that environment and collect the temperature at all the points. It may be possible that you can apply some sensor and you can collect the temperature at one or 2 points, but if you want to take decision, you need the full picture of that particular environment, and which is possible only with the help of the camera image. So if we can make our system that much intelligent, which can collect the intelligent information from the image, we can solve the problem. So we also did the same in our use case. We already installed thermal camera in our kiln. That thermal camera, you can say, visualized and monitored by the operators in DCS, process operator, and they just see the image, and on the basis of this image they take a number of decisions. We have to increase the feed, we have to decrease the feed, but it's not possible that human can identify 24-hour real time. So we just create that model, that model is doing the same thing. It's collecting the data, it's taking, you can say, intelligent information from the data, and on the basis of it is taking action. It is also connected with the DCS, means to say DCS data is connected with our AI model, computer vision model, and confirmation, because equipment is very high running cost, so we cannot take risk. So it's one input is coming from computer vision, one input is coming from the DCS, and they combine take the decision. So still we are recommending only, we are not giving auto command, but as per the analysis we are receiving, we can automate this very soon. So this is the concept I just described, that we utilize how we. It's not running. So this is the simple we discuss with, because without domain expertise, any AI project will not give that much benefit which is expected. So we discuss with domain expert in process and identify the use case, then only we take this challenge that okay, we can do that. So this is we use a number of model, but after analysis and CNN structure analysis, we identify the mask or CNN result was very good, and it's giving really very good result and little bit mimic the human intelligence. This is the zone, it's up to 16 degrees centigrade, 1600 degrees, so it's not possible to sustain any kind of sensor in that environment. So there is only one way, thermal camera image, and make your system in such a way which can collect intelligent information from this camera. So we also recommend that you have to decrease the coal, increase the coal, or any kind of anomaly we can detect in advance, because it's real time. So if anomaly identify, we can recommend to operators. Now this is the use case related to mines. As you can see, this is the crusher. In a mines, in cement industry, we have to blast and collect the big size limestone, then crush in a crusher. Crusher are two types, jaw crusher and cone crusher. So jaw crusher is designed to convert the big size stone in little bit small size, then in cone crusher it converted into very small size. So this is the use case related to jaw crusher. So when we analyze this use case, we identify for last 3 years we get at least 150 plus hour loss just because of this jaw crusher jamming. We just consider the loss of production, means to say if limestone is not coming, then clinkerization will not take place. And now condition in cement industry is that is a hand to mouth. If you have clinker, then only you can produce cement. So when we considered this use case was very useful and we worked this. And as you can see, this is the use case. If in any way I can identify, this is the you can say jaw crusher area and this is grizzly area. Stones are coming and crushing at that area. So if in any way I can detect the jamming in advance, because it is not possible that within a millisecond jam will occur. There is a process, jam will take place. So we identify these use cases and we able to predict this jamming condition. And now this jamming condition can be solved with the help of two ways. Either it's the initial jamming or fully jam condition. What is initial jamming? Sometimes small jam is there, but stone are continuously moving, so it's converted into the big jam. And sometimes the size of stone is that much big which is not able to crush. So in first case we solve the problem just by getting input from our computer vision model and delayed this grizzly process, rock feeder process. And in second way, where the size of stone is very big, so in that case we have rock breaker installed, and we tried, we didn't implemented this. We tried that this can also be automated, that if jam is there, computer, means to say camera can see all the environment and it's automatically go inside this area and crush the stone and jamming will occur, jamming will open. So this is the third use case. We have done n number of use cases. These are the small use cases. If you will learn about computer vision and AI, small use cases like human detection as unidentified area is very easy. This is the mask based algorithm result. You can PP detection, computer vision is very easy. Vehicle speed measurement is very easy without any big investment, just a good camera and your algorithm. Conveyor belt running, is a conveyor belt is running or not running is the major challenge in a cement industry. Sometimes idle running is there. It's the electricity cost, electricity consumption. Now we talk about the way forward. We are also identified a number of use cases related to computer vision. So these are the some use cases, like we recently start railway loading in our plant. So there is also 2 to 3 use cases available. One person is there who check each and every wagon that there is some problem in wagon or not. If problem in wagon means to say some part of wagon is damaged, so if we put some loose material like clinker, so it will be fall down. So this task we are completing with the help of computer vision. And one person is dedicated just for recording the wagon number written on each and every wagon, because in a railway there is a proper sequence that if 58 wagons are coming, then 58 will go down in a sequence in which they are coming. So we can also do with the help of computer vision. We have AFR system, so this can also be solved in a AFR system. We have a number of use cases like fire detection in AFR area, and sometime machine running idle, material is not there but machine is running, which can also do. Now, and the implementation of agentic AI. As we were talking about since morning, that agentic AI, we are not expert, but we identify that what is agentic AI. If we solve a number of problems with the help of AI and create a system which is able to solve the problem with the help of developed agent, we can use agentic AI. So we all know that it is the future, and it's you can say can change the way of working. because lots of repeated work can be converted into automated. Not only in manufacturing side, but application side we can also see. But in manufacturing side, this can do n number of tasks, which is currently done by the woman. They can support the woman. If woman is taking decision by 10 inputs, they can provide 1000 inputs to user in a way they can take decision, data-based decisions.
Thank you, sir. It was very informative and gave us a clear understanding of how computer vision and artificial intelligence are transforming the cement manufacturing industry.